Devil's Tower isn't rock. That's the claim. Watch enough videos on this, and you'll hear it stated as flatly as a weather report. That 800-foot monolith rising out of the Wyoming grassland is not stone at all. It's a stump, not a metaphor, not a comparison. A stump. The sawed-off, weathered base of a tree that once stood so tall it would have scraped past the cruising altitude of a commercial jet. Somewhere in the neighborhood of 9,000 feet. Here's the part that should stop you before you laugh this off. This isn't some video with 400 views and bad lighting. Clips making this exact claim have pulled in tens of millions of views across TikTok and Instagram. That's more people than will ever open a peer-reviewed geology journal in their lives, combined. More reach in a single afternoon than the entire discipline of structural geology gets in a decade of publishing. You won't find this idea in a textbook. You won't find it in a museum placard. What you'll find, if you go looking, is a name, the giant ancient trees hypothesis, and a claim that goes something like this. Earth was once covered in trees of an almost unthinkable scale. Not redwoods, not sequoias. Something taller than any forest that has ever been photographed, mapped, or fossilized in the record we currently trust. And when those trees were felled, cut, burned, or torn down in some forgotten catastrophe, what was left behind is what you're looking at every time you see a mesa, a butte, or a flat-topped mountain. This is not a story about mountains. This is not a story about trees. This is a story about what happens when a claim this large collides with a science that has spent over a century mapping exactly how rock forms, and somehow still can't fully agree on its own answers. Stay with me, because there's a number buried in this story. A ceiling. A hard physical limit on how tall a tree is even allowed to grow before its own biology stops it cold. Nobody talks about that number in the viral version of this theory. We'll get to it. And when we do, it's going to matter more than anything you've heard so far. But first, you need to understand what a mesa actually is, and where this idea that they used to be trees actually came from. Devil's Tower sits in Crook County, Wyoming, rising almost 800 feet straight up out of the surrounding pine forest and grassland. Geologists call it a laccolith, or possibly a volcanic neck, or possibly something else entirely. We'll get to that disagreement in a moment. What matters right now is what it looks like. Vertical, almost hexagonal columns run up its sides like the world's largest pipe organ, and the top is nearly flat. From a distance, especially in the right light, it really does look like something was cut. That's not a new observation. And this is where it gets interesting, because the idea that Devil's Tower looks like something other than an ordinary rock formation didn't start on social media. It's centuries old. Here's what the textbooks leave out. Long before anyone filmed a video calling this a tree stump, the Kiowa and Lakota peoples who lived across this land told a very different story about those same vertical grooves. In their traditions, the marks running down the tower's sides were left by the claws of an enormous bear, clawing at the rock as it tried to reach children who had climbed to safety on top. The tower grew upward beneath them as they climbed, pushed skyward by something beyond ordinary explanation, and the bear's claws carved the grooves you can still see today. Notice what that story and the tree stump theory actually have in common. Neither one treats Devil's Tower as an accident of geology. Both insist that something happened here, something dramatic, something that left a mark, something too strange for a plain explanation. The bear story doesn't pretend to be science. It was never meant to be. It's an explanation passed down for generations, carrying its own kind of truth about awe and land and memory. But ask yourself why the tree stump theory borrows that same emotional shape: catastrophe, violence, a giant force acting on the landscape, while dressing it up in the language of biology and geology instead of myth. That's not an accident, it's a formula. And once you notice it, you'll start seeing it everywhere this theory goes. So what does modern geology actually say happened here? Not folklore, not a viral hypothesis, The measured, dated, peer-reviewed version, that's where things get more complicated than you'd expect. Geologists have been staring at Devil's Tower since the 1880s, and here's the strange part. They still don't fully agree on how it formed. Geologists Carpenter and Russell were among the first to study it seriously, back in the late 19th century. Their conclusion was that the tower formed from an igneous intrusion, molten rock forced up into existing sedimentary layers, cooling and hardening underground long before erosion ever exposed it to daylight. In 1907, geologists Darton and O'Hara pushed the idea further, arguing the tower was the eroded remnant of something called a laccolith, a dome-shaped blister of cooled magma that never quite reached the surface. That was the accepted story for decades. Then, in 2015, a research team led by geologist Jiří Závada published a paper in the journal Geosphere that complicated things. Závada's model proposed something different, not a buried blister of magma, but a lava coulée, a thick, slow-moving flow of lava that pooled inside a volcanic crater and cooled from the outside in, leaving the distinctive columns you see today. Here's the problem with that explanation, and it's the same problem with almost every explanation offered since 1882. It works, mostly. It accounts for the columns, the flat top, the overall shape. But it doesn't fully explain why some of the joints inside the tower are tilted while others run straight up and down, or exactly how deep the original magma source sat, or why erosion carved away one side of the structure faster than the other. Modern geologists agree on the broad outline. They do not agree on the mechanics. Sit with that for a second. This is one of the most heavily studied rock formations in North America, protected as a national monument since 1906, climbed and cored and mapped for over a century, and professional geologists are still publishing competing models about exactly how it took shape. That gap is not proof that the tree stump theory is right. It isn't. But it is real. It is documented in the peer-reviewed literature, and it is exactly the kind of crack that a theory like this one is built to slide into. Where there's genuine scientific disagreement, there's room for someone to say, maybe the geologists have missed something bigger, and that's exactly where this story is about to go. So here's where we stand. An old story about a bear and a rescue. A newer story, backed by real data that still can't settle its own internal arguments after more than a century of trying. Two explanations. Neither one complete. If you're finding this as strange as I am, do me a favor and hit subscribe. This channel exists for exactly this kind of gap. The place where the official record goes quiet and something else moves in to fill it. Drop a comment too, because I want to know which explanation you trust more before you hear what's coming next, because now we get to the part of this story that made it spread in the first place. Not the bear. Not the geologists. The theory that says everyone, folklore and science both, has been missing the real answer standing right in front of them. The giant ancient trees hypothesis doesn't come from a university or a research institute. Its clearest written form comes from an unnamed writer publishing under the banner of a fringe science website called Secret Energy, in an essay describing what the author calls petrified silicone tree stumps. And this is where it gets complicated, because the argument isn't as lazy as you might expect. The claim goes like this: mesas and buttes aren't sedimentary rock shaped by wind and water over millions of years. They're the severed bases of trees so massive that a single trunk could have covered the footprint of a small town. Look at the vertical striations running down a butte's face, the theory says, and you're not looking at rock strata. You're looking at bark. Look at the flat, level top of a mesa, and you're not looking at an erosion-resistant caprock. You're looking at a cut, clean, deliberate, made by something with the power to fell a tree taller than the tallest skyscraper on Earth. To back this up, proponents point to General Sherman, a giant sequoia in California, and the largest living tree by volume on the planet today. Nearly 275 feet tall. with a trunk that could swallow a two-car garage at its base. If a tree can grow that large now, the argument goes, who's to say something didn't grow far larger once before whatever event erased it from the fossil record? And here's where the forbidden text comes in. Several of the most shared versions of this theory tie the giant trees to the Book of Enoch, a text that describes fallen angels called the Watchers teaching forbidden knowledge to early humanity before a catastrophic flood. The Book of Enoch never made it into most Bibles. It was excluded from the standard canon by the 4th century, preserved almost entirely through Ethiopian Orthodox tradition, and largely rediscovered by Western scholars only in the 18th century. To the people spreading this theory, that exclusion isn't incidental. It's proof that someone, at some point, decided this was a story the rest of us weren't supposed to keep, stacker it all together. Visual pattern. A real record-holding tree, a genuinely suppressed ancient text, and you can see why this spreads. It doesn't feel like nonsense. It feels like a puzzle with real pieces. So now, the number I told you to remember. There is a hard physical ceiling on how tall a tree can grow, and it has nothing to do with strength or wood density. It comes down to water. A tree pulls water up from its roots to its highest leaves using nothing but the physics of surface tension and evaporation. A process called transpiration pull, moving water through microscopic tubes called xylem. As a tree gets taller, gravity and friction fight that process harder and harder. Somewhere around 300 to 400 feet, the math breaks. The water column can no longer be pulled up fast enough to keep the highest leaves alive. Hyperion, the tallest documented tree currently standing, tops out at 380 feet. And even it is pushing close to that theoretical limit. 9,000 feet isn't a stretch past that ceiling. It's not even in the same universe as that ceiling. It's roughly 23 times taller than the tallest tree ever measured. No fossil record, anywhere on Earth, shows plant life remotely approaching that scale. Not in the Carboniferous swamps, not in the Mesozoic forests, not anywhere researchers have drilled a core sample or read a growth ring. Geologist David Bresson, who has written extensively on Devil's Tower's formation, points to something else the theory doesn't address at all: mineralogy. If Devil's Tower or the Grand Mesa were once living wood, the rock should preserve some trace of organic cellular structure, the way genuinely petrified wood does, cell by cell, at places like the Petrified Forest in Arizona, less than a day's drive from some of the most cited giant tree formations online. It doesn't. The fact-checking outlet Science Feedback reviewed the claim directly and found no mineralogical evidence anywhere tying these landforms to wood tissue of any kind. A conclusion built on over a century of structural and sedimentary geology. So the pieces that made this theory feel solid, the bark-like striations, the flat-cut tops, the comparison to General Sherman, all have ordinary explanations once you look closely. Striations are sedimentary layering. Flat tops are erosion-resistant caprock. General Sherman is real, but it's nowhere close to 9,000 feet, and biology won't let anything get there. And yet, here's the part that should genuinely unsettle you. None of that has slowed this theory down online. If anything, the debunking videos get a fraction of the views the original claims do. You now know the physics. You know the mineralogy. You know where the forbidden text actually comes from, and why it was excluded. Most of the millions of people who've watched this theory spread never will. So where does that leave you? 3 unresolved questions, not one. First, why do these shapes trick the eye so effectively that a claim with zero mineralogical support can still feel, in the moment you're looking at a photo of Devil's Tower, almost plausible? Second, why professional geologists, with cores, dating methods, and over a century of published research, still can't fully agree on the exact mechanics of how a single, heavily studied formation like this one came to exist. And third, the one that matters most. Why a theory that loses every technical argument it's ever been put up against keeps winning the only contest that seems to count anymore: Attention, this is not a story about mesas. This is not a story about trees, real or imagined. It's a story about which explanations get chosen, and by whom, and why the version with the most dramatic shape tends to travel farther than the version with the most evidence. Nobody in this story is lying to you, exactly. The geologists aren't hiding anything. Their disagreements are published, dated, and public for anyone willing to read them. The theory's proponents aren't fabricating the photos. The striations and flat tops are real, and they do look like something. The only thing missing is the specific piece of physics that makes the leap from interesting to impossible. And that piece rarely survives the trip from a research paper into a 15-second video. So here's the question I'll leave you with. If a theory this large gets rejected by every geologist who studies these formations directly, but still convinces millions of people scrolling past it late at night, what does that actually say about who we trust to tell us what the ground beneath us is made of? The people who've spent careers coring, dating, and mapping the rock, or the 15 seconds that made you stop scrolling? Let me know where you land in the comments. I have a feeling this one's going to split the room. Outro file, outro.txt. We have only just touched a part of this mystery, but the real question lies in your perspective. What do you think about the giant ancient trees theory? Do the shapes of masses and buttes point to something science hasn't caught up to yet? Or is this a perfect example of how far a compelling image can travel without any evidence behind it? Is there anything we missed? Leave your thoughts in the comments section below. I am always here to discuss and listen to your deeper insights. Outro image prompt. A detailed pen and ink historical illustration in National Geographic documentary editorial style, depicting a lone scholar in a dark study filled with manuscripts, looking out at a starry sky or a candle flame, holding a weathered book. Chiaroscuro lighting with a single amber gold candle glow illuminating the scene, aged parchment background fading into deep charcoal shadow. Reflective and mysterious mood, 16:9 horizontal composition, Google Flow optimized.